follow uh, rules for hybridization. அது ஸ்டக் ஆகுது, முடிச்சிடலாம் அதை. Okay, understood. So rules for hybridization. So here I am giving clearly. Just listen. Add. First rule is called what? Add all the valence electron. Add all the valence electron. Suppose if it is less than or equal to 8 means you just divided by 2. If it is greater than 8 means what? You just divided by 8. Okay. Third one, if it is anion means what? If it is anion means, for example, SO4 2 minus, add the charge. You just remember this one. Add the charge. Suppose if it is cation means what? If it is cation means what? Current means I am saying NH4 plus. Okay. You subtract the charge. Subtract the charge. Understood? Right. One more rule I will give. Suppose sometimes two coefficient will be there. Two quotients will be there. In that case, you should do add all the quotients. And final remainder. So this rule we should know. Okay. Then now I come to the example. So it's simple one, very simple. You must know valence electron. Otherwise, you cannot able to do this. Valence electron, hydrogen, helium, correct or not? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, fluorine. Yeah, no. So, atomic number, 2, 3, this is all, correct or not? 7, 8, 9, 10. Okay. Then valence electron only we want. We don't want any atomic number, but we want only valence electron. Valence electron for this one means what? We just write. Very important. Not only this lesson, for all the lesson. Okay, 1, 2. Again 3, no. 3 have to split. 2, 1. So again valence means the electron present in the last cell, no. Again 1, 2, 3, 4, 5, 6, 7, 8. Understood? Right. Then after neon we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Understood? So as usual, atomic number, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Understood? Right? Okay, this will be 19. Right? Okay. So valence electron means here, valence electron. First you must know atomic number. Generally we can able to find out the valence electron. So here 11 how to split? 2, 8, 1, no. So 1 is a valence electron. Likewise here 2. Here 2, 8, 3, no. 3. 2, 8, 4, 4. So here 5, 6, 7, 8. Again this potassium how to split? 2, 8, 8, 1. Correct? So 1 is the valence electron. So here 2 is the valence electron. Understood? This valence electron you must remember. Okay. Then only it will be easy. Okay. Now I will take one examples how to find out the hybridization of these molecules. Simple, for example, best example usually I will take PCl5. PCl5 means phosphorus. How many phosphorus? See, number of atom 1. Correct or not? Number of phosphorus 1 into its valence electron. Its valence electron I told you, its valence electron is what? Phosphorus. See that? Phosphorus. The following phosphorus valence electron is what? Phosphorus valence electron is 5. I given no? Right. Phosphorus valence electron is 5. Right. So 1 into 5, 5. Correct or not? Chlorine. Chlorine, how many chlorine? We have 5 chlorine. No. So 5 into its valence electron. So 5 into its valence electron. Sorry. Its valence electron is what? Okay. I'll write it once again. Just listen. Okay. Now, chlorine, 5 chlorine. No. Its valence. Chlorine, I given no. Chlorine valence electron is 7. No. So 7 in 5 into 7, 35. So totally what? We have 40. Correct or not? 40. 40 means what? See the rule. Second rule. Second point. Second rule. Second point. If it is greater than 8 divided by 8. Greater than 8 மேல இருந்துச்சுனா என்ன பண்ணணும்? Divide by 8. So what? So 40 by 8. So what is the quotient? We have 5. What's the remainder? We have 0. So you just value how to find it means value is equal to support. Add quotient plus remainder. No, 5 plus 0, 5. 5 means what? We can say what? 1 s orbital, 3 p orbital, 1 d orbital. Okay. You just, but I didn't give this one. You just remember the value. If the value is, if value comes, 2 is coming means we can say what? What kind of hybridization? We have sp. If 3 is coming means sp2. If 4 is coming means what? sp3. If 5 is coming, sp3 d. If 6 is coming what? sp3 d2. Are you following? If 7 is coming, sp3 d3. This is all just keep in mind. Now we get the value 5, no? We get 5 means what? sp3 d hybridization. Are you following? Okay. The first examples. Okay. Can I go to the next one? See the next example. See, I'll write it here. One more examples. Okay. Simple example. Water molecule. What is the hybridization of water? Okay. Oxygen in water molecule. They lost like this. Okay. The middle element of hybridization we can able to find out. So as usual, hydrogen is what? How many hydrogen? We have 2, no? So but 2 into its valence electron is what? 1. So 2. Oxygen, how many oxygen atom? We have only 1, no? Its valence electron is what? 6. So what? 6. Totally 8. 8 means what? I told see the rule. Rule number second. If it is 8 or less than 8. If it is 8 or less than 8 divided by 2. Correct or not? The total valence electron is 8 or less than 8. So you should divide it by only 2. If you divide by only 2 means we quotient. What's the quotient? We get 4, no? What is there any remainder? Remainder also 0. So value means, just remember 4 plus 0. So answer 4. 4 means what? What kind of hybridization? See that I given clearly sp3 hybridization. Simple. Understood? Right? So one more examples I'll give. Third one is, suppose xenon F6. How to find out xenon means, all the noble gas having, how many xenon here? Only 1, no. All the noble gas having except helium. All the noble gas having 8 electrons, no. So 1 into 8 in 8. Correct or not? Fluorine. How many fluorine atom? We have 6, no. So 6 into 7, 42. 42 means, 50. 50, it is greater than 8, no. So 50 means divided by 8. What's the quotient? Quotient 1 is what? I think 6 times, no. Cut. Remainder is very, very important. Remainder we have 2. If you have remainder 1 means you can leave it. Sometimes you remainder 2, 3, 4 like that means you take that 2, you do one more process. Okay, you take this 2, one more process. Then we get another quotient, no. So Q2 is equal to, we get 1, but R2 is equal to, we have 0. I told what are the rules I given? If any, I given, no. What are the rules? What are the rules I given, no? Add, if any 2 times quotient, 2 times remainder means add all the quotients and final remainder. Correct or not? Add all the quotients and final remainder. So what? Now, Okay, so add all. You just remember, you put like this, then only it will be easy. Otherwise, very tough. Add all the quotient. Add all the quotient. Q1 plus Q2 plus R2, which is equal to what? 6 plus 1 plus 0. So we have 7. 7 means what? sp3 D3 hybridization. Very important. Are you following? Understood? So this is a way to find out. Understood? Right. One more example I will give. Suppose SO4 2 minus. How to find out? 1 sulfur. 1 into sulfur means valence electron 6. Correct or not? 6. 1 oxygen. How many oxygen here? We have 4 oxygen. 4 same family. Sulfur and oxygen belong to same family. This also having 6 valence electron. So 24. Okay. Charge, is a minus means what? Anion. Correct or not? Minus 2. I told you, minus 2 means plus 2. Now add. So what? 32. 32 means, so quotient, what? 32 means what we should do? 32 by 8. Correct or not? Quotient 1, 4 times. Remainder 1, 0. So value is what? Value 4. 4 means what? sp3 hybridization. Correct or not? 1 s orbital, 3 p orbital, then only we get 4. Understood? Right. One more thing. NH4 plus. Now, as usual, it's a cation complex. So 1 into, that valence electron 5. Correct or not? 5. Hydrogen 4 hydrogen. No. So 4 into 1. So what? 4. It's a cation. No. Cation means I told you. Cation means you 1 plus 1 is there. So you have to put minus 1 here. Cation means subtract the charge. So 5 plus 4, 9. 9 minus 1, 8. 8 means what? 8 by 2. So what's the quotient? Quotient 1 means 4. Remainder 1 means, 0. So value is equal to what? 4 plus 0, which is equal to 4. 4 means what? sp3 hybridization. Are you following? Simple. Okay. So molecules having what kind of hybridization we can able to find out. Understood? That's all. Then one more small topic I'll take. That is, hydrogen bonding. Okay, you just remember only just definition only. Hydrogen bonding. Hydrogen bonding means whenever hydrogen is bonded to highly electronegative element, it may be fluorine or it may be oxygen, it may be nitrogen. So whenever hydrogen is bonded to highly electronegative element, so this is called hydrogen bonding. It is represented by dotted electrostatic force, dotted lines. Okay, so we have 2 types. What are the 2 types? Intermolecular hydrogen bonding, intramolecular hydrogen bonding. Inter means we have 2 types. I'll write it here. Intramolecular hydrogen bonding. Simply remember, hydrogen bonding is present between the 2 molecules. Inter means always what? Inter means the meaning is called what? Between. Between. Correct or not? Intra means meaning is called what? Within. Okay. The hydrogen bonding is present within the molecule. Here, hydrogen bonding is present between the molecule. Hydrogen bonding is present. Okay. Right. Hydrogen bonding is present between the molecule. Understood? Just write the definition. Here hydrogen bonding is present present within the molecule. So present within the, here between the molecule, underline, here within the molecule. correct or not? So best example is, here between the two molecules, no. So it may be ethanol formula CH3 CH2 OH, no. Between, water, what is the formula for water? H2O, no. So outright hydrogen of this, oxygen of this, correct or not? Okay. So hydrogen bonding is present between what? Between what? Ethanol and water molecule. Hydrogen bonding is present between ethanol and water molecule. Are you following? Right. So intramolecular means, it mostly organic compound. This will be best example. If you take phenol, if I put NO2 means what? Orthonitrophenol. Okay, orthonitrophenol. So here, this is only one molecule. In this molecule, the hydrogen bonding is present. How the hydrogen bonding is present means it is, it is in between, no. H of here I put dot lines, no. Correct or not? Okay. So H of bond between H and O. This is within the molecule. This is called intramolecular hydrogen bonding. Okay. Then one more point you just remember. If any compounds having intermolecular hydrogen bonding, it will be what? High boiling point and high solubility. These are two reasons. Many compounds are highly soluble in water means it has intermolecular hydrogen bonding. But this is quite opposite. So if any compounds having intramolecular hydrogen bonding, it will be low boiling point and low solubility. Are you following? Okay. Right. So these are things about in molecular structure and chemical bonding. Okay. Just go through. Any doubt means you can ask me. Okay. Practice all this. So go through your textbook also. Thank you, students.